Hello and welcome. I'm Watson Williams, and you're watching Cryptic Creations, where we bring you the not so obvious. Today is September 2nd, 2019, and today we want to talk about one of the ideas I've been working on over the past year or so. It's a work in progress, but it is having to do with probability theory, and it takes its starting point from playing Mega Millions, the lottery, the big jackpot lottery that's popular here in the United States. And this is what I was initially doing. I was measuring the jackpot balls one at a time, seen here in the red star. This is the real jackpot from April 5th, and the jackpot on that day for Mega Millions was 8, 22, 24, 38, 64, 21. And if you take the DS, what I'm calling the divergent sum, DS value for short, uh, and it is the sum of the absolute value of the difference between the numbers that you picked and the numbers that hit the jackpot pick. And if you hit the jackpot, then the DS value would be 0. Now, as we branched off into just more abstract mathematical considerations and interests and pursuits, we dropped the uh, we ignored the Powerball and only focus on the first 5 balls that come out of 1 through 70. And in pondering the possibility or the claim, rather, that all lottery combinations are equally likely, for instance, uh, my dad told me or tells me that that his dad told him. I never heard this, but it seems reasonable. I don't have any reason to doubt it. It's not anecdotal, but I mean, it might be from your perspective, but um, it's been said at least that 1, 2, 3, 4, 5 is just as likely as 8, 22, 24, 38, 64. But I got to thinking that, or I eventually came to realize that all lottery numbers, when compared just 1 to 1, they're all equally likely. They are. But by class, they are not all equally likely. And I came up with a way to define geometric classes within this 1 through 70, uh, not really matrix, but just number of balls that you can pick from. And oh goodness. Okay, so skipping a lot of details here and with no script, I want to show you what the geometric standard that I came up with looks like if my computer will cooperate. Okay, so this is what it looks like in the square matrix here. We select the the ideal geometric standard. We're right in the dead center, and then here, here, and here. Let's look at, that's 69, pick 5, because I was also looking at Powerball. But okay, so combination 70, pick 5, ideal geometric standard is here. It's 11.5, 23.5, 35.5, 47.5, and 59.5. And in between each standard point, like you can just look at this as a measuring stick. And for all possible picks out of 70 pick 5, of which there are 12,300 and excuse me, 103,014 possibilities. Uh, yeah, that's 12,103,014, and they all get measured against the standard that is geometrically perfect, as close as it can be to, because see, since if there were 72 balls, then you could pick evenly in between them all, right? Because 72 divided by 5, actually no, you divide it by 6 because because you're trying to count the number of divisions. So that would be 72 divided by 6 would give you 12 balls in between all of them. But this is absolutely close to perfection as you can get with 70 balls and having to pick 5 of them out. And we don't pick any, or we don't pick any balls. We pick in between them. That's just the method that I came up with. And I had to work my way up to 70 pick 5 by studying the patterns in 70 pick 2. And I actually worked my way up to that by just having increasing sample sizes of pick 2. So I started with just 2 pick 2, and then moved up to 3 pick 2, to 4 pick 2, 5 pick 2, 6 pick 2, 7 pick 2, etc. Until at about, I think like 13 pick, or 14 pick 2, I was able to induce this same procedure for 70 pick 2. And what we're seeing here is that, so the number of possibilities are here in these in blue text in parentheses. There are 15 for 6 pick 2. The standard here is perfect, right across the middle. Nothing left over that's not even between them, if you're following me. And so one of the main axioms here is that for however many geometric classes the standard produces, if you add up the number of elements in each one of the geometric classes, in other words, the class sizes, if you add up all the class sizes, then you will get the total number of possible combinations. Total number of possible combinations for 6 pick 2 is 15 possible combinations. They're right here. And if you add up the size of the 4 geometric classes that the standard produces, which is 4 plus 6 plus 3 plus 2, you also get 15. And that's pretty straightforward, but it's like less obvious if you had not worked your way up to that realization from smaller samples. Like if you were just looking at 70 pick 5, and you're like, oh, what's going on here? But okay, so that's why we work our way up. And we worked our way up and we got to 70 pick 2, 70 pick 2, right? And there are 2,415 possible combinations for 70 pick 2, and they look like this whenever you line them all up. That's this, you know, it grows, it gets bigger and bigger as the sample size increases, and it starts to look more and more regular. And yeah, here it is for 13 pick 2. And I didn't draw the triangle matrix for the DS values on that one, but the triangle matrix DS values of 70 pick 2 is this live file in Excel, but that's just a screenshot of it, so we can't interact with it. Here's another screenshot of it, And yeah, I figured out the pattern, and then I figured out that the largest class was the 23rd geometric class, both by just looking at the obviously it was here, but then yeah, so it's this one, the tallest one, obviously. It's the 23rd class. But then looking at it geometrically allowed me to infer the largest geometric class for 70 pick 5. And the way that you do that in sum is it is the pick, it is the combination that has the greatest extent without overlap. Because what you want to see is that you have an extreme farthest away, and one is as close as it can be. And that puts you in the 23rd class in this case, in 70 pick 2. And we do transformations. We do algebraic transformations. So if you go one closer to the first standard, you have to go one farther away from the second standard on either side to keep the value of 23. And this is 92 possible combinations. Um, so, as you get farther away, yeah, and so the greatest extent without having overlap is the midpoint. And that puts you at, well, you could pick 1236 or you could pick 3536 because 12 and 35 are the same distance away from 23.5. They're both 11 off, right? So, hurry the up. Okay, 23.5 minus 12 is 11.5, and then 23.5 minus 35 is also 11.5. Okay, so that's my point. Point is that, and then so if you picked, this is 10, 20, 30, 31, 32, 33, 34, 35. If you pick 35 and 36, see how they're equidistant from their respective standard points from S1 and S2 here. And any farther that you would go would cause the same ball to be picked. Like if you went up from the first one, you went up one from the first, you'd be picking 36 and 36, and you just can't even do that. But if you overlapped, like you went one farther and one closer slash farther, but then you wanted uh, to measure them against the same standards. Like if you wanted to measure, this might be TMI. Okay, I think you get the picture. And then I was able to extrapolate that to 70 pick 5 and determine that the largest geometric class for 70 pick 5 was the 26th class. And the way that I determined that was by seeing the same thing. Like you count out 5, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 puts you here and here. And you do that for like yeah, if you're doing that for the first two, so then for the third and the fourth, you could come out 5 and 5, you'd be here and here, and then uh yeah, for the fifth one, 5 off on either side. And so yeah, I don't know how much time I have left because my screen thing like glitched out. I can't even see my timer. And I guess with the time that I have left, I just want to try to explain that I'm in the process right now, these days, where this project is now is I'm